evening, everyone. Today, I, Chanima Pal, on the behalf of DSC BPMT, giving you a warm welcome to everyone for our webinar on demystifying the network mechanism of the intelligent system. Let me give you a brief idea about the agenda of today's webinar, starting with the introduction to ML and DL libraries, TensorFlow universe, deep learning. Moving on, we will also learn about the code review with TensorFlow and demo of different projects built with TensorFlow. Now, let me tell you about today's speaker. A technophile and Flutter developer, Vishwas considers experimenting the key to the technology. As a student, he was a part of different communities. He has also been a part of the community meetups and Event Computer Architecture Club, Google Crowdsource, the Pi, and AI Bangalore chapter IEEE, and more. So, without further ado, I will hand over the mic to our speaker, Mr. Vishwas N.
So, hey everybody, this is me, Vishwas Nayan. So, basically, about me, I just started out as an EC student. I chose a branch which was not even related to any of the things that I'll be teaching here. So, none of the things that I'll be teaching here will be related to it. And also, over a course of time, I realized one thing that you need to fall in love with the problem statement. So, that's where I started my own podcast and it's on my channel, so you guys can go check it out and you guys can see the podcast. I've done with some great folks in the industry like technical architects, evangelists, developer advocates, authors of different books. It ranges from all different parts of the things. So I'll be using a simple whiteboard from this place. I just love it when I write something called as a deep learning, and I just love it. I just love the fact that it's so easy for me that I don't have to do much here. So if you want, you guys can go back to my LinkedIn. Sorry for that. I don't keep my things open up every time. So you guys can go check out my feature section in my LinkedIn. So in this featured section, you will get an access to ample amount of resources, the slides that I have done, the collab notebook that I have created. Like I always tend to create a lot of notebooks, and sometimes I miss out on some of the things. So if you have specific needs, come back to me. I'll just take all of it. But if you have okay with that, just go ahead and just do it. I don't update it very frequently, but most of it is there. But for this entire thing that I had planned for, I have planned this notebook and I've planned a visual transformers as well as just an introduction on how to handle data sets and how to plot all these kind of models on over the course of time. Like, because I believe that, if I just give you a blunt introduction about like what is this ML and everything, let me show you my slide share, which was an 8 slide share. Slide share is here, which was an 8. So yeah, this is my link for the slide share. So you guys can go check out my slide share here. So it contains all the slides from the different topics that I did. I think probably this is the funniest one, the missile system that I did. I don't know. Like if I fall in love with that subject, I just go deliver a talk. I just do some projects. I look out for some internships. So this was when I was an intern in a company, and I think lately I think pretty much have changed here. Apparently there will be a lot of changes in my career, don't worry. So let's just go ahead and understand by seeing the code itself, because to me over a course of time I want you guys to be thorough with the semantics of the TensorFlow over becoming very well versed with the concepts. So a simple trick to become very well versed with the concept, it's what is that notification? Okay, I have logged in, so that's fine. So there are some channels which I say, I think Deep AI. I think this is one of the biggest Twitter handles that I follow, and this has the best collection of papers. You guys can go there, check out, just follow this Twitter handle. You will get to know how much of paper gets released over a course of time. And there is one more resource called as archive.org. So if you guys can go and type this URL, so it's a wonder. Like you get every paper, and you will be amazed by the fact that there will be around 150 plus publications minimum every day that will be announced. And time, this is actually an internal project from Cornell University. It's from an professor called as Andrej Karpati from Cornell University itself. So Cornell has a huge share here. Like they literally have their own contributions going on every single day, and like amazing papers come out. Like this is one of the repositories that I always look back to when I am thinking of new concepts. So let's just go ahead and see what is this all about. So you see that there is an import statement. It's very simple. What this is just doing here is it's just taking your OS information and putting it, oh, sorry, putting it in the form of the file system. It's a file system at the end of the day. So when you think of all these things, you think of a NumPy, it's still a file system. How? I'll show you how. Because when you go to GitHub NumPy, it's one of the best things that you can really see, because this has an end-to-end solution for your neural network. Whatever you think of the TensorFlow, PyTorch, everything has a backend of NumPy itself. I think if you really want to understand what is this, Travis Oliphant, Lex Friedman, yes, you have to go and study this podcast. Like, trust me, like, if you really want to understand what is this entire thing all about, this open source thing, which is running this entire data science world, you need to go and study this podcast. I think subscribe to my channel as well, because it gives me a lot of things. I think morning I had 1.03. I don't know, somebody has unsubscribed from my channel. So just go ahead and subscribe to my channel. It gives me a lot of enthusiasm in the future as well. And also go back to this channel, subscribe to this channel as well. That's from Lex Friedman, by the way, an amazing researcher and mind blowing. So, end of the resources, end of the talk. So, let's just go back to this. So, every time you have a mathematical backend, so I can say this as a mathematical backend, because every numpy operations that you are seeing here is basically an array which is taken care. So any sequential data, let it be in the form of a text, let it be in the form of an image, let it be in the form of a voice, let it be in the form of anything combined together, right? It's all considered as a sequential data. We'll see why is there a sequential data called every single time, because lately I have realized one thing, that when you don't have a backend which is mathematical, that abstraction has no value. Like I'll say you why. Because TensorFlow has given out a lot of versions. TensorFlow stable version just got released right now, right? 2.8.0, that's all right. Is TensorFlow 2.6.0? Yes, it's stable. But to be very frank, this semantics and this semantics has a completely a different, like, all the semantics here that I'm talking here in terms of the TensorFlow will have a lot and lot of differences. Like, I can show you some of my old projects as well. They still have no meaning if I don't just go ahead and just do it. So I think computer vision, yeah, I think computer vision learning, I think this is the basics. I think machine learning for everything. GAN's fashion amnest, yes, I think this is one of the best thing that I can show you. So every semantics is going to change. Like, I might be using some code from other places. And if you think of tf.function, this got introduced in your TensorFlow 2.0 version itself. Like, when it was a beta version, there was a realization that, hey, there is something called as base estimators in sklearn, so we need to use that. So this is what TensorFlow functions was all about. similar functionality, but an advanced abstractions can be done. Like in terms of knowledge distillation, you can have your own way of analyzing what is this happening, what is that entire neural network working, so on. So lately, this H5 model is just an other abbreviation to say that, hey, my model will be in the form of an H5 file format. So there are different ways that you can tackle it, but I want an easy way to do that. So somebody has written a file for it, so we are just implementing it. Of course, you guys know why we need Matplotlib, because we need to plot some things. So basically, plotting is not just one. Image processing is also taken care, because it's similar to MATLAB. So anybody who is an electronics guy here, I think probably should be knowing MATLAB, because it's like one of the kind of a simulation tool that we still use. It's basically image processing as well. So you need not have to worry about any of the things that you're considering. Of course, all these things have their own backend, and I'll be explaining it in using my board. So any EC folks here, EC folks, EC, or everybody is CS here? Everybody belongs to the computer science proclivity. Nobody belongs to the electronics.
Most of them are CS, I guess.
Yeah, okay, fine. That's perfect. That's perfect. So let's see what is this all about. So you have TensorFlow as TF. Of course, I can't explain the basics of Python here, but basically I just can show you what is it all about. So Keras, yes, I think Keras actually started out as a GSOC project. sklearn also started out as a GSOC project. I'll say you what is the reason all about. So now just think of a sequential data which is in a form of an biggest array. Like it's like 100 cross array, 100 cross 100, 1000 cross 1000. What will you do? So there is always a mechanism in your layers that says that, hey, let's do one thing. Let's not take 100 cross 100. It's going to become more complex. Let's just flatten it out. It's just simple form factor like this. So you have an image which is like this, which is like this, which is like this, which is like this. Let's say it's 100 cross 100 here. And now that 100 cross 100 to be computed all of the sudden is going to be very hectic. So what they do is 100 cross 100 is like 1, 2, 3, 4. So it's almost like 10,000 elements that are taken into the consideration. And now they are flattened out like this. So this is where your flatten comes into the picture. Whatever you're seeing here is just an abstraction of the code, which is taken from the TensorFlow. Next is an abstraction of the code which is taken from the Keras into the TensorFlow. Now it's all about flattening it. Like, how can I really do it? So, what if something goes wrong out there, and what if I can't really build on it? So, this is where it is. And the next one is a dense layer. It's nothing but an abstraction code for your dense neural network. So, dense neural network. So basically we call it as DNN. So let me just open a file which says that. So okay, before that I need to give you an Keras from Francois Chality. Keras as an GSOC project. GSOC project. So I think it started out as an GSOC project itself. So GSOC info page. I think it's from Francois Chality. Yeah, I think he's the creator of Keras, by the way. He's the creator, and sklearn started as a GSOC project. Yes. So sklearn, the library that I'm showing here, is a GSOC project, by the way. It was actually a GSOC project. So creator of sklearn, sorry, I forgot his name. It's David. Yeah, it's David. So Google Summer of Project 2007. Here you go. 2007 it started as a GSOC project. And amazing, man. When you think of all these kinds of projects coming out lately, I think there are amazing projects like Pomegranate and everything. So you guys can go check out that as well. So I think he's now in Google. I don't think so. I think Travis Oliphant has his own company. I think this guy also has his own company. Let's see whether this guy has his own. Well, I'm not a fan of PyTest. Yep. I'm also not a fan of PyTest. Don't worry. It's like writing a test code for your deep learning is good, but not to an extent where you spoil the performance, right? So, yeah. So DNN was all about like, okay, you have layers and layers of neural networks stacked together, but every neural network has an tf.nn function and tf.max or min functions and everything. And they have their own activation function, they have their own criticalities behind, right? So if you really want to just neglect all these and just go ahead and call in function, this is where your TensorFlow comes into the picture. So your TensorFlow keras.layers, you're saying that it's going to be a very dense layer and it's going to have a lot and lot of neural networks which will be taken care into the consideration. So just make sure that I'm just importing that as a dense, and this is what your function is all about. And over a course of time, you actually on parsing through your neural network, you also have a feedback which is called as a back propagation. I think just don't fall in love with my scenario is like I do a lot of freelancing for different companies. I also take care of different deep learning projects in different sectors, but I don't take too much of an NLP. To be very frank, I took one, I just left that because I was not able to go ahead and do all these things. But I would say you one thing like DNN, neural network, arcsine. If you just go ahead and just type in that paper, arcsine has an amazing set of papers. You guys can go check out any amount of papers that you want. You will have it. I think 2011 was an amazing paper. I think using a single neural network, I think this paper is actually good. So you guys can go check out this paper, by the way, 2011. So it's basically 2020 11th month. So do check out this paper, by the way, because it's going to be a lot of. Oh, Chandrima Pal is from ECE. So nice. So you should be knowing all these kind of bad assignments they gave and everything. So you guys can see that, right? There are different layers and there are different ways of connecting it, and there are feedback loops which always go out from one layer to the other. So it's actually basically from an output to any of the input that you'd really desire to give, but basically we don't have that much of time, so we just go ahead and give it for all the neural network these days. And this is what your entire import statements were all about. So it's all about like, how can I really get this neural network? And of course, sparse categorical cross entropy is a kind of a loss. So it's a very simple thing, don't have to worry about it. I think I can go through and sparse categorical cross entropy formula. Yes, I can go ahead and I can show you this. Apache has done an amazing job in doing it. So actually, this is a company which takes care of DevOps. DevOps is an amazing thing. So you guys can go check out all these. But I don't know what's the magic with these people. They have their own charm in the industry. These conference guys, they have their own charm in the industry. So you guys can go check out all these kind of sparse categorical cross entropy losses. So basically, it's still going to be a log version of all these activation function and the outputs. But yet, how are you really minimizing and maximizing the ways in which you are seeing zeros and ones and that's that entire input? So this is what your sparse categorical cross entropy is all about. So over a course of time, when you think of all different possibilities of, hey, what if my entire neural network has to be stable, it has to not go for 100% accuracy, but yet it has to give me an amazing output like 99.9% accuracy, and it still has to still be that accurate. You still need losses. Why losses? Because there are chances where your neural network can overlearn something, underlearn something. So in order to just remove all that complexity, you need that at the end of the day. And to be very frank with you, If you don't know what is going to happen in your neural network, don't worry. There are amazing tools called as Optune and Hypertune. Optuna, hyperparameter tuning, or else Hypertune is also there. But I would say Optuna is an amazing one. So you go ahead, use this for your hyperparameter tuning. What is this hyperparameter tuning? It's all about like what should go inside an neural network, what should be the activation function, what should be the loss percentage, and everything will be taken care directly from this. So you guys can go check out all these things. So I think this is one of the best ways that I can give you as an easy thing. So all is sys is always the go-to size of, and the version I've used 2.6.0 version. Yes, that's a stable release by the way. And accuracy in the matrices, I'm just taking care of the matrices from this library because I don't want to do all the things from my side, right? I just want this to just go and get all the things. So I'm just doing that. So it's a very simple thing. After doing all these kind of imports for that is required for measuring my neural network input and output and everything, I'm just curious like what should I be doing. So what I do is I just have some data sets. So I'm just taking care of this function here, get file size, because I want to know what is going to happen with huge files systems, right? So what I've just done is I just written a function saying that, hey, os.path get size of the file and the file path, and it's just going to say me what is the file path, and based on that I will be manipulating my data set as well. So in order to do that, over a course of time, scientists have realized one thing, that what, we can't just give out the code just like that. If it's in kbs and mbs, we need to have a sort of a processing, we need to have a technique to do that. So it's a very simple thing here. So I am like, okay, fine, whatever might be the mbs or the kbs it is, let's take the file size here, let's take it as a string, and now just divide the size by 1024, because I'll say what 1024 is all about. 1024 is basically the pixel aspect that I'm taking here. So it's like how much of that entire screen can be filled with this pixel. So it's like 1024, fine. So it's two dimensions. So now what, this two dimensions is basically the color and the transparency. But I'm saying, okay, let's just take one thing. Let's go three dimensional, because RGB, red, green, and blue, is what I'm considering here. And I need 1024 cross 3. That is what I really require here. And now I am like, okay, fine, this is in KBs. That's okay. But if it's in MB, that data rate is going to be very heavy. So I'm doing 1024 cross 1024 and three dimension. It's still RGB, and now I'm getting it in a form of megabytes and bytes, and simple as that, it just does its magic. And afterwards I'm like, okay, fine, collecting data set, like writing this neural network code, everything requires time, because I can show you one of this cassava data set here. I think cassava is what I was working here, so I think this is the cassava data set. I think GANs here is working pretty well. I think you guys can still use this notebook, don't worry. Yeah, it's still the same old explanation, the same old neural network that I gave here. It's still going to be affecting that. So just take your time, just start doing that work, and everything will be sorted for you, folks. I think, yeah, still the same old functions. Yeah, I think let's see the neural network. Don't worry, don't get afraid. I'm just talking neural network. That's it. I have not done anything here. So I told sequential, right? The sequential is also here. So GANs is here. So oh yeah, oh this is that. Sorry, it's still going to be sequential, but yet it's going to be GANs. Perfect. Let's be there. So it's just basically generating the fashion MNIST data set on its own. So that's it. So I think you guys can just take that as a reference, but still use this as one of the reference that you require. I think this is not having TF serving. I think one more notebook had a TF serving, where it is now. But let's see. So it's a simple thing for me. I'm like, okay, fine. there is an fashionableness variable which does all these function. I am saying, hey, Mr. Kiras, you have some public data set which are available, so just get me. So it's very simple. TensorFlow public data set is here. So you guys can go check out the amount of data sets that are already there here. I think tf.datasets, any amount of data sets will be available for you. Like, this is like one of the best part about TensorFlow is that you don't have to research much about the data set. Everything is being clean, everything has been done. Like, it's all about that. So basically, when you think of the data science process, it starts from collecting data, processing data, then keeping it back for training. So this is what it is. And also Keras also has some public data set as well. So I think I'm not finding that. Wait, I think models and data sets. Of course, you guys can go check out TensorFlow Hub, TensorFlow JS, TensorFlow official data sets are here. So yes, I think this article should give you that one thing, like collection of different data sets were there. I think B data set is there. Cassava data set is also there. Cassava data set. Cassava data set, TensorFlow data set. All right. So yeah, I got it. So different problem statements has different things. So for image classification, there is a different thing. Object detection, there is a different thing here. So I think I can go ahead with catalog and an overview, and you guys can copy any amount of data sets here. So this is the link. So it's very simple. It's tensorflow.org, datasets, catalog, overview. Simple as that. So just go ahead and just do that. So everything is sorted. So I did I share this? No, I didn't share this. So do go ahead. Just demystify what is DevOps. DevOps is an amazing subject. I have many talks on it in my channel as well, so you guys can go check out as well. So I think let's just go ahead and just demystify some more. So I'm saying, okay, boss, we have already delivered a lot of data set and chaos. So just divide it as train and test labels, and everything. So test images will have test labels, train images will have train images. So to be very frank, in your neural network, this will be your X train, this will be your Y train. Oh, sorry for that. So sorry. Y train, what happened? It's not coming up here. So yes, let's just do this. So this will be your, why is this not taking anything? So this will be a Y train. I'm not able to write this. Why is this happening? Are you guys able to see my screen? Okay, everything is working fine, but like writing is impossible here. So okay, this will be a Y train. This will be your Y test. Sorry, this will be your X test. Wait, let me just think about it. Simple as that. This will be your X train. This will be your Y train. This will be a X test. This will be a Y test. So X variables is basically the data sets. The Y variable is basically the annotations of it. So this is what you give. At the end of the day, I've segregated it. Just go ahead and give me the sorted. I think this should give me the notebook. I think it's working here now. So X train data, X test, like test data, Y train annotate, Y test is basically test annotate. So this is what we are thinking about, right? Every time that you are just thinking about a neural network which you are just training, these are some of the variables that you just get back to, right? Oh, sorry for that. I think this is what your entire architecture will be. So over a course of time, this is what your entire neural network and architecture will be segregated. So this will be your X train. This will be your X test. Oh, sorry for that. This will be a Y train. This will be an X test. This will be your Y test. So that's it. So you have all the annotations and everything plotted. I don't know why they don't give me this option and zoom it, else everything would be fine. So you know that, okay, in now in that same data set you have almost 10 classes. Yes, it's 10 classes only, not almost, it's just 10 classes itself. And you're saying that, hey, you know what, let's annotate them as it is. Let's just take the class names and let's just start working towards it. And later on, you know that you have just done all the classes and everything sorted, and now you want the shape of the data set. So it's just saying it's 60,000 of those images, and it's 28 cross 28 samples. So it's a simple thing, it's just an image. If I can do a text here, it's just 28 cross 28. So whatever you are seeing here as in 28 cross 28 will be the dimension of this. So it's 28 here, 28 on the left side. So it's 28 cross 28 and into 3. But to make my life very easier, I've just made it a binary image. That's your black and white image. So the data will either be 1 or 0. In layman words, it's just quantization that I did. I'm just saying, okay, if it's a data set, just like 255, just name it as 1. Or else, even if it comes in the range of somewhere around 200, just name it as 1. So that is what I did over a course of time. And over a course of time, I just knew that length of the train labels is as soon as it's 60,000. It should be 60,000. So it's still 60,000. And there are annotations that are done for every classes. So the 0 that I'm talking here is basically the t-shirt top. The 0 that I'm talking here is basically the t-shirt top. So it will be still be the same old 0. So the 0 and the 0 here is just going to be awesome. So 1 will be your trousers, 2 will be your pullovers, 3 will be your dress, 4 will be your coat. So 1, 2, 3, 4, 0, 1, 2, 3, 4. So it's basically ordered in that way itself. So you now have 10 classes. That's also perfect. And you're saying that how much is the uniqueness of it. So of course, it's still going to be the same old way of annotating it, but what next? Here you have it. And then you have the test data set, and basically your test data set and train data set won't be same, because the amount of data set that you take while collecting, you actually will be making sure that you annotate them and you just separate them out in a different way. So let's say this will be the entire chunk of the data, and if you think 60,000 of the data set is here, 10,000 is for the testing data set. And over a course of time, you realize that there is a 20% ratio almost, and there is an 80% ratio almost that is taken care. But it's 1 is to 6 that is taken care. But it depends on your data set. How are you going to do it? But this is how you do it. And like if you want to really have an paper and things like that, forget the fact that this exists. Like let me just show you one more thing. So this is an entire box of collected data. So let's just do it. So let's say you keep 70% for training and you keep 15% for testing, and the other 50% is for the validation. What is a validation? Validation is just like you still know that this model is 90%, but yet let's just take some random data from the collected data itself and let's just test it. Because in your papers, you really don't want to give a false result, right? So what you do is just make sure that you start using all these kind of techniques. And there are different ways to do it. There is Monte Carlo way of doing data segregation. There's k-fold way of doing data segregation and everything. So it's basically k-fold at the end of the day, but data segregation is another topic. So don't worry about that. So this is what it is. Then later on, you just define the keras.sequential, and you still use the same old flattens, and you still say that, hey, I need 10 dense layers here, and the input data set will be of the dimension 28 cross 28. That's perfect. But dense data set will have an input of 128 at one given point of time. And this relu activation function is basically that you're saying that, okay, I now need a mathematical function of all the pixels that are getting it, and how relu activation function is taken care. And that's it. Then later on, what you do is model.summary. Oh, sorry for that. I think I did a wrong way of doing it. So model.summary is just saying that what is the nature of your output. So we defined it as a sequential model, and we still know we need to define a layer type. Of course, it's all a flattened inputs that are coming in. There are dense layers. Output shape is not yet defined, but the dimensionality of it is going to be defined. So this is what 784 is taken care. 128 is also taken care. And the dense one is like the output out layer, and how many layers will be there as an output. Like in the output neural network, how many neurons will be there. So since we had 10 classes, there are 10 neurons which are saying that, hey, this is belongs to class 1, class 0, class 1, class 2, up to class 9. So this is what 10 is all about. So you're doing all that, and think of the number of parameters that you're considering here. So all these things that I'm plotting here will be going towards the same old dense layer computation that you're doing, and what next will be taken care here. So the number of parameters is around 100,000, which is pretty less compared to the advanced neural networks like transformers and that we are considering. I think you guys can use this transformer neural network as well, so that you guys can understand like how low code and no code platforms are also taken care of here. So you guys can go check out this link. So it's available for you folks. And of course, you know that you have built a model. Now let's start compiling it. So compiling it requires some optimizers. What are these optimizers? So what is the code you have here? Whatever was the definition of the parameters that are taken care. Also, the number of parameters in the output. So to say that, hey, this t-shirt has to look like this face has to be like that for this kind of a dress and everything. And to care of all the flattens that have been already done so that there is no noise that is being added by a neural network, you use an optimizer. And this completes the entire compilation process and says that, hey, boss, let's see, we are only considering one matrix, that's accuracy, for all these parameters that I'm considering in, and I'm still using the sparse categorical cross entropy. Log it, yes, I'm saying log all the different matrices that come out while you're optimizing, while you're considering all the losses and everything. And what you get at the end of the day is this output. So this entire thing says that, hey, there's a 27% loss in the first epoch, that is first round of training with first batch of data that you're considering. Then the second round of training happens with 25%. Then it reaches down to around 23 point something percentage. Now, basically, with all that data set, also, what you can really acquire is a 91% accuracy. So that's pretty good for number of parameters that we are considering, number of training that we are doing. And now I'm saying that, okay, boss, let's just save this model as H5. So TF model fashion MNEST will be saved in my source folder here. Since I've not connected it, it will not be connected right now. Or I'll just run and I'll show you later as well. So don't worry for that. I think probably the version of TensorFlow might go wrong. I edited it very late, but still the semantics still remains the same. Then later on, you're just bringing it down for the accuracy and you're testing the model. How you test the model? I just converted the model here, but you really need not have to worry about the testing and the converting of the model. You just need to take care. Okay, let me just test the model. So now you put some inputs here, and now you start working towards it. And later on, you know that okay, there is some numpy arrays that are coming in. That's cool. And later, what you just do is you're just converting it and deploying it and just saying out, hey, the model file size was almost this much, so what to do next? Then it's all about like how do you really get back to that entire test data set. So what I just did was a simple thing. I just took the model, I just built it as, hey, let me just invoke that model over an interpreter and now just give it as an input for the test data set. And now as soon as that test data set flows inside that neural network architecture, was that model that I have trained, it will start predicting. And now this gave me around 87.9% accuracy. That's pretty cool. Even after converting the model, we are getting this much amount of accuracy. That's pretty awesome. And every intelligent system, let me take any of it, like, sorry for that. I think somebody had posted something. Pritam, yeah, let's do this. Translate. So I don't know this entire language. I think this is Bengali. The script looks very Bengali, by the way. Like, is this Bengali? Like, I just want you guys to say, is that Bengali or anything? Like, I don't know. Like, so yeah, I think it says, Pritam, what are you doing, brother? So Pritam Kai Koreshi Bai. So this is what this. Yeah, it still says the same. Yeah, it's spoken Bengali. So yeah, it's still Bengali at the end of the day. What they do is they take the data, they sequentialize it, they throw it inside a neural network after pre-processing it. By the way, there are some noises added, there might be some symbols, there might be some emojis, and everything. So they pre-process it, then they throw it inside a neural network, then they do the same old churning. Then later for the deployment, they convert it, and now they just deploy it over a course of time. But basically, they'll be testing it again and again with the new set of data set, new batch of data set, and everything will be taken care over a course of time. That's it from my side, folks. If you really want to understand what is this entire thing about basic, till you just write the neural network, I just wrote an demo notebook for you folks so that you guys can understand what is this all about when we are talking about all this. So that's it from my side. So any intelligent system, whether you go for NASA, Google, or anywhere, it still remains the same. So I think we are pretty good in explaining whatever is required for you to write a neural network architecture. So just reach out to me if you have any other questions. And that's it from my side, folks. Any questions, do drop it down in the comment section. Also, turn on your speakers. We'll just go ahead and answer all your queries. So that's it. Hello.
Hi, so you're done? So, yeah,
Yeah,
let's wait for some time, couple of minutes if there is some question. Otherwise, I will upload the recording to YouTube.
sure, perfect. So I think have you made note of all the links that I've sent for this entire thing?
It is recorded, so I will get all those.
Okay, okay. If you get all those, just put it down in the description saying that link shared in the
Okay.
session.
Otherwise, if it is not, I don't know. It gives. You can give me in the chat in the LinkedIn, and I will give it in the description.
Yeah, yeah, sure, sure. Yeah, I'll just keep it in the link then. So I think perfect. Any queries,
Yeah.
do turn off your mute button and just ask me because that level of functionality is available for you folks now. So just go ahead and do that. I think yes. Subscribe to my channel, by the way, folks. I have an amazing podcast which is lined up, which is coming up, so you guys can start learning about it. So yeah.
I guess there is no question. So we can wrap it up here and yeah.
Thank you so much, folks. Thank you so much.